Okay, from today we are going to discuss about corneal topography, or I don't know, tomography. So it's part one, and today we are going to just discuss about going to discuss introductory part, a little bit about cornea, a little bit about topography, and then I think in corneal topography we will move, I think, 15-20 videos. I don't know how much. Let's see how deeply we can delve into corneal topography, because it's my favorite topic of all time. So let's move forward, and slowly we will go make a little bit step by step. Okay. So the first thing I always start my class is the difference between topography and tomography. That's why I choose the topic tomography and topography both, because in regular days we talk about corneal topography, but actually it's not topography, it's tomography, isn't it? So actually topos means the topos means place, and the graphia means the recording or whatever. At the same time, tomos means it means slice. Okay, it means slice. Actually, we in corneal topography we can see layers: front surface, back surface, not just surface. If we talk about just surface, then we have to talk about topography. Isn't it? Description, surface characteristics, like surface of this tab or surface of the anything. But if you can see beyond that surface, that 3D, isn't it? So it's not 2D, but 2D images and gathering 2D images. When we gather and we come to 3D, that layers, like for example, optical coherence tomography, isn't it? OCT. So you can just see the topograph retina from surface. In tomography, you see retina from layer, isn't it? The nerve fiber layer and outer plexiform, inner plexiform, and RP. You see layers, isn't it? Layers in maculum, layers in other retinal part. So that's why it's called optical coherence tomography. So tomography means you see layers. Okay, it's layers, slices, and topography means the surface. Okay, fine. So basically means this topography of urban core of New York metropolitan area. So this is the basically topography from the above. We see just topography, line, surface. But whenever see MRI, what we will see? Societal topography, societal tomography. So we see layers. This top, this layer, and again layer. We are going down, 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 isn't it? So even our face can see, we can see layers by layers, by from top to bottom layers, isn't it? And that's called tomography. So what is this normal shape of the cornea? Because we are going to discuss about corneal topography. So first we have to know the normal shape of the cornea. So many people just, cornea is not at all spherical, not at all. But prolate is spheric. It's very important. What is prolate and what is spheric? And the reverse pattern is oblate, which is abnormal, and for example after radial keratotomy. Okay, but oblate pattern is definitely reverse of prolate, or maximally cornea is prolate. And the central 4 mm approximate is spherical. That's very important point. So cornea is not spherical, definitely cornea is prolate spheric, but central 4 mm of the cornea is approximately, just emphasizing the word approximately, spherical. However, corneal curvature flattens, it is progressively towards the periphery. That's the definition of prolate. Prolate means from center to periphery, if you move, then the radius of curvature increases. It means it becomes flatter and flatter and flatter. It means the curvature decreases from center to periphery. You know the difference between curvature and the radius of curvature, isn't it? They are exactly opposite thing. From center to periphery, radius of curvature increases, isn't it? But curvature decreases, because curvature and radius of curvature is exactly opposite thing. So, if in cornea from center to periphery, curvature flattens, curvature decrease. At the same time, radius of curvature increase, and that's the definition of prolate. That is prolate. Oblate means exactly opposite. From center to periphery, radius of curvature decrease, curvature increase, and that's the definition of oblate. Oblate means that. Okay, so that's basically prolate and oblate. So prolate shape effectively reduces the spherical aberration. That prolate shape chosen by nature, it's not like out of whim. It actually does the great thing. That is, it reduces the spherical aberration. If suppose cornea is spherical completely, then spherical aberration would go much, much, much higher, and it will definitely create a reduction of sharp vision, because it will create aberration, and that aberration definitely creates not point focus, but yes, spread focus, and that will definitely create problem. So, although it complicates the contact lens design, center optical and periphery fit poor and position adequately. Although, because if it is, if cornea is spherical, then contact lens would be simpler, isn't it? The design of contact lens, but that's not the case. We have conquered already contact lens and make designs like it's aspheric, and that's why in contact lens, center curvature, and then we have second curvature more flat, third curvature more flatter than second, and fourth curvature is flattest of all, isn't it, to match exactly corneal shape. So that's the contact lens design. So I will discuss on contact lens series because I don't want to touch it now, but if I touch to contact lens, then I'll make like more than 100 videos. So I'll let's not discuss about the contact lens right now. Let's move. So that's what I am talking about. Sphere means the radius of curvature remains constant, isn't it? That's the definition of a sphere. Whenever you take here, this is R, you take here, this is R, it doesn't matter. Sphere means R is basically circle in 2 dimension, and sphere is 3 dimensional. Same word, isn't it? Prolate means center R is smaller, radius of curvature, and periphery R is larger. Center curvature is larger, periphery curvature is smaller. Oblate is exactly same. Center R is larger, peripheral R is smaller, radius of curvature, which means center curvature is flatter and periphery curvature is steeper. Okay, and that's very important. Now we will discuss about it in later on one video, that what is prolate, what is oblate, what is hyperbola, what is parabola. I am thinking about it. I will make one video. Okay. So what happens here? The small changes in corneal shape do occur throughout the life. In infancy, definitely cornea is fairly spherical. In childhood and adolescence, probably due to the eyelid pressure, the tissue cornea becomes slightly astigmatism, that is with the rule. It's very important. Why we call with the rule? The many people have that corneal topography. That's why it's with the rule. And with the rule, the reason till now what we have conquered is eyelid pressure and young and middle-aged cornea tend to recover its sphericity, and the late life it's from with the rule, it again back to against the rule. So basically, at birth against the rule, young with the rule, and old age again against the rule. From young and old age is same, isn't it? Okay. What happens if cornea is spherical? I have already told you. When the light ray passes through the spherical refractive surface, paraxial rays are less refracted than the peripheral rays. Definitely, peripheral rays refract more because of angle of refraction, and the peripheral rays is a paraxial rays. And then what happens? It's basically spherical aberration, isn't it? That's all what I'm talking. So this. So peripheral ray bend there and spherical. I have already discussed about it in spherical in aberration optics. Just go there and you can read. And whenever a surface is aspheric, the spherical aberration is way less. I don't. I never told you that spherical aberration is zero. It's not. It's not that. There is spherical aberration, and we have benefit of having spherical aberration. One of the great benefit is depth of focus, definitely. But we don't want too much, and we don't want exactly sharp focus. Sharp focus will also create a kind of curse, which is lack of depth of focus, and that will create problem, isn't it? So, so this is the way. Center, we think this is center and of cornea in paracentral, peripheral and limbal area. Okay, central approximately 4, paracentral 7 to 8 mm, peripheral up to 11 mm, and beyond that is limbal. Basically, that's how we see. And central cornea is very important in case of refraction. So that's refraction in case of foveal vision. That's why till today, though we have topography, but we don't use topography for cataract surgery, normal cataract surgery. Uh, Keratometry do the good job. Why? Because not always, but yes, definitely. Uh, normal corneas, normal cases, keratometry do a good job because keratometry gives the central 2 to 3 zone curvature, and that curvature matters if we really think about the central vision. Okay, that's why. So I just touched this slide. This is last slide. The instrument non-contact are either quantitative and qualitative, either reflection based, projection based, or symptom based. So I just want to discuss about few things. There are few instruments. So keratometry, golden of all time. So quality reflection based, definitely. Keratoplasty, placido disc, and photokeratoplasty is quantitative reflection. Video keratoplasty, projection based. Slit photography, off scan. Okay, so there are other things, even more interference, and then I will briefly discuss about them because I want to touch them as a history. And definitely today's corneal topography is Simflong based. That's fantastic. And we have Pentacam, Bone Cirrus, and Galilee. I haven't seen Galilee and I haven't worked with Galilee, but definitely with Pentacam and Bone Cirrus, and with a lot with Bone Cirrus. So I'll definitely show you some maps and discuss some maps in depth possible. Okay, so that's it for today. I think the great books I want to recommend, who doesn't know, who don't know Sinjab sir. So Sinjab sir is all time favorite, great book, and I'm in love with this book. Okay, by Ming Wing. I don't know why I'm in love with this book. I always recommend residents, optometry student to read this book. I always recommend everyone in my life, in my conferences. I have always recommend this book as a guide, and I'm obviously in love with this book with Dimitri as our for corneal topography, and definitely I'm reading refractive surgery last year, and I'm currently reading too. So this book is also good. So I think Sinjab sir, definitely, it's you don't have any other option besides him. But definitely, I'm in love with this book, Atlas and Clinical References Guide for Corneal Topography by Mang Wung and others, I think team. And definitely this book, I think it will be a little bit burdensome with this refractive surgery for optometry students especially. So don't touch this book. I think corneal topography chapter is best if you can go there. But yes, these three books you can refer, and definitely I'm in love with this refractive surgery book by Dimitri. Tiajar, I don't know about you. You can try. Okay, so I think that's it. That's the first video of corneal topography, and we will discuss later on more and more. Okay, so bis dann, tschüss.